Now I should mention real quick that there is a way to make even this implementation a little bit faster. So instead of making the bubbles themselves lists, I can make the bubbles sets. So let me just explain what a set is real quick. So I did mention this in class briefly, but a set is a collection of items without an order. So so there's a set. If I say x dot add 0, x doesn't actually change because 0 is already there. It turns out it's faster to say something like this. This Boolean expression is evaluated more quickly, 1 in x, than it would be if this were a list. And it's also faster to concatenate. Or, I guess, no, that's not true. But it is much faster to find the elements in it. And we'll see why later in the course when we talk about binary trees and binary heaps. Okay. So that's all I have to do, and this code is actually exactly the same because, now instead of being a list of lists, this is a list of sets. But I do have to change the union code because that is not the way you add sets technically. I don't think it's going to like that. Yeah. So the way you add sets, there's a couple ways. You can say x.union. Okay, that's not going to do anything. Let's see, if I say y is equal to this set, maybe 2, 3, 4, x dot union y, well, that's all the elements that they have in common. That's going to give me a new set, 0, 1, 2, which they have in common, 3, 4. Another shorthand for this is x or y. So it's all the elements that belong either to x or y. So in this case, instead of saying plus equals, I say self.bubble IDX. Let me see, I think I can say x or equals y. That should work. Let me try that. Whenever I'm not sure, I test it out here. Yeah, okay, so I should be able to say instead of plus equals or equals. All right, so let me just run this again, make sure that it still works. So I'll say s is equal to my disjoint set 10. Just to show you that the bubbles are a little different now. Okay, it's a list of sets. And let me remember which ones I did. Okay, 0, 2, 1, 8, 8, 7. S.union. Did I already forget what I said? 0, 2, 1, 8, 8, 7. Oops. S.union 8, 7. So let's just check to make sure that this worked out the same way. So it looks like it did. Now notice, I mean, the order doesn't matter, right? It never did. But the sets happen to order them lexicographically, so in sorted order. Okay, fine. So that's how you do this with sets. I just wanted to point that out. This implementation is a little faster, and this is the one that we'll test in the assignment when we go to time things. Okay.